part of Group D12 on the Arduino Programming and Hardware Interface class. This is our sprint 2 of the final Arduino project design.
All right, so real quick, I'm just going to go through two of these sensors. We have our barometer sensor, and we have our 3-axis digital accelerometer here. Right here we have the barometer code running. You can see it's printing out both the temperature, pressure in pascals, the related atmosphere in ATMs, and the altitude in meters. This is mildly accurate. If I raise this up to the ceiling, you can see that, it's taken about 3 feet have been picked up. If I bring it back down, it's gone back down. It's about accurate within about a meter, meter and a half. And I think that those estimates can be refined with better code. The other one we have is the 3-axis digital accelerometer. This is kind of a gyroscope sensor. And code for that is right here. So the way that works is it prints out kind of this these 3 X, Y, and Z values. And that is determined on the orientation of this. So if I move it so it's oriented like this, these and hold it steady, these values will remain mostly steady. If I tilt it, these values will change. So we plan to use these as well, probably 1 or 2 of these accelerometers as well as this barometer to get some position, altitude, and general location readings that we can use for kind of determining the general position, orientation, and location of our aircraft. This stuff is all attached to a Grove shield kit right here, which allows for us to easily just attach and detach these sensors. Yeah, that's about it. Now, Titus is gonna walk us through the build of the plane. Peace.
Okay, so now let's see what we got so far for the design. As you can see, our team has been very busy. We've built the entire airframe, the wheels, the control surfaces, the wing, and installed the servos and motor onto the airplane. Currently, the servos are all hooked up to control surfaces with control rods. Our wheels are attached, and then our propeller is attached and spins. We also have wired the propeller and servos up to bring the wires into the main electronics bay here. The battery is in the top of the nose, under the bottom there. I'll show you that in just a minute. Right now, all of the wires for the servos are just wired together on a breadboard and then go into this receiver right here. This receiver will connect to this DXE Spectrum transmitter. So this transmitter, you just control the joysticks and it sends PWM signals to the receiver. Currently we just have the receiver hooked up to the servos, but in the final design we will have an Arduino capable of switching between control using the receiver and control using the Arduino. We're still working out the details on how exactly that will work, but we have some ideas, including using a transistor to disconnect the servos using the Arduino. Alright, so let's power it up and see everything move. Okay, now let me power on the plane and I'll show you how the control surfaces work. Okay. I'm going to set the plane here so it doesn't roll. Alright, we have our transmitter here. Make sure that the propeller is disarmed. And then as you can see, when I move the sticks, the elevators go up and down. And we also have the rudder moving left and right, and our ailerons. Okay, and as you can see, the plane is just about ready to fly. Currently, it is in a state where it can fly by itself with the transmitter, but our goal is to incorporate the Arduino to give it autopilot capabilities, and also add a payload drop section to drop our package. So the remaining steps are to add a system to drop the package, which is it's a servo release, and a package with a parachute, and also add an Arduino, which uses sensor data from the GPS, gyroscope, and barometric pressure sensor to control the plane once it is in the air. Currently, I am working on the plane here, and Henry is working on the electronics, including the Arduino, and Daniel is working on the coding and also the payload drop system. And yeah, so starting Tuesday and also after Thanksgiving break, we'll work to incorporate all these pieces together into the plane.